Hello and welcome to the channel. Today we're going to be talking about how to use a DualShock controller, a PlayStation style controller, with an OpenAI gym environment, specifically using Pygame as our interface. The same techniques can apply to using a controller for other things, to using it to control, other types of environments, an actual game in Pygame. I've used this technique to control a physical robot arm. So there are several different scenarios where this is useful. The main reason that I've used in a reinforcement learning context, and you might be asking yourself, if you're familiar with OpenAI Gym and what it's usually used for, you might be asking yourself, why would you ever want to physically control your gym environment? Because, the whole point is that you are using an AI or an agent and it is learning to play the environment or learning to solve the environment. So the reason I started using controllers was in more complex environments. So if you've watched some of my other videos, I've got a couple of series out there on robot arms and doing, object manipulation with a simulated robot arm. And in some of those cases, it was necessary to actually show the agent how to do the task over and above just, it was never going to stumble across something that was going to give it a reward. It was a sparse reward space. And in that sparse reward space, it was necessary to give it some examples, some human examples of what it needed to do in order to be successful. So what we're going to do today, we are going to go ahead and actually use the Lunar lander environment, and we are going to wire it up with a standard USB DualShock controller. I'm using something really simple, a Logitech controller I think I bought for $16 or $17 on Amazon, and I'll give you a link in the description to that. And we're going to set that up with Pygame so that it can take controller inputs and feed those into the Lunar lander environment. So without further discussion, let's go ahead and get started. I'm going to use Conda to create our environment. If you're not using Conda or you just want to install the packages in your default Python, you're more than welcome to. So if you are using Conda, what I'm doing here is Conda create -- name CTR demo lunar lander Python 3.11. So we're going to run that and say yes, and that is going to set up our Python environment. Let's go ahead and fire up VS Code here, and I am going to create a new folder. This part is firmly optional. I've got a whole nother video on how to automate tasks in VS Code. So I'm not going to go into that now. I'm just going to copy and paste. But long story short, this task.json is going to let me fire off the project with a key press. All right, that just makes my life easier as we are coding. So I'm going to create two files here. Or actually three files. I'm going to create a main.py. I'm going to go ahead and create a joystick controller.py. And I'm going to create a requirements.txt, because of course we need that. So our only requirements are going to be gymnasium, and in square brackets you're going to put box 2D, and then you're going to do Pygame, and then you're going to do NumPy. Okay, so let's go back to our terminal, and I'm just going to conda activate CTR demo lunar lander and pip install -r requirements.txt. That should go ahead and pull in our requirements. If you're using a different system, you can, obviously just pip install each one of those individually. Your approach may vary here very slightly. So because I'm using VS Code, I'm going to select the Python interpreter and pick my CTR demo Lunar lander. And at this point, we have our Python environment set up with the appropriate packages so that we can go ahead and start building. So one of the things I like to do is abstract away some of the controller code. So I'm going to say, I'm going to import NumPy as NP. I'm going to import Pygame because that's what we're using. And then I'm going to create a class controller. And in here, we will have our init method, as always. And we need to initialize Pygame. So to initialize Pygame, we are going to call pygame.init, pygame.joystick.init. And then we'll go ahead and declare our joystick. Now this is going to assume when you run the code that you already have a controller plugged in. Also, we're saying joystick. This is not just for the joysticks on the controller. This object is going to represent the entire controller. So I'm going to say self.joystick is equal to pygame.joystick.joystick. And the 0th joystick, so the first one. And then we'll say self.joystick.init. All right, and in the interest of testing code as we go, let's go ahead and come over here to main.py, and we're going to say from joystick controller, import controller, and we're going to say controller equals controller. And I'm just going to run that, and I get hello from the Pygame community. Cool. So we've had no errors in the code so far. Let's go ahead and we're going to create a get action method here. So what this is going to be is we're basically in the main.py, we're going to be looping over and over again. And on every loop, we're going to call get action from our controller. And if there's an action, we're going to do something with it. If there's no action, we are just going to, going to go ahead and pass a non-action to our process. So I'm going to set up get action and pass it self. And we're going to start out with a NumPy array. So let's do np.zeros and let's give ourselves space for 5. And what I'm doing here, and there are probably a few different ways to handle this, but I'm starting out initializing an array of a NumPy array of numbers and those will represent potential actions. So at a super high level, what we're going to be doing is something like action. I know this isn't NumPy. I just want to show what this might look like. So we might have 1 0 1 0. Why not? And let's say this one represents the left joystick controller, the left, stick there. And it represents the left stick on the x-axis, so side to side. So you could say that a 1 is joystick push to the right, a -1 is joystick push to the left. That's not necessarily what we're doing here, but it is going to give you, a general idea of what we're trying to accomplish. So we've got action equals np.zeros. Now we're going to do action 0 is equal to self.joystick.getAxis 0, and action 1 is equal to self.joystick.getAxis 1. Okay, Now, we want those to be we want to map those into different actions in the action list. So what we're going to do is we're going to start by doing some reversing. This was just something I found helped for me because they went in the wrong direction for me. So we're going to go ahead. Actually, you know what? Let's leave the manipulation alone for a moment, and we'll come back and do some of that manipulation a little bit later. I'm going to keep this really simple for now. So one of the things that's going to come out of this, and we'll just go ahead and return action. Let me show you what this does right now with no other changes. So we're going to say while true, yes, we're creating an infinite loop. Action is equal to controller dot get action, and we will say print action, and let's go ahead and up at the top, let's import time. Import time dot sleep, and we're just going to sleep for 0.1 seconds. We're going to sleep for 1/10 of a second. Okay, so you notice down here, and I'm not using the controller at this point. So you'll notice that our two axes here, our two slots in our array, are coming back with very, very small 0.003 values. And that's because it's just getting some signal from the joystick, because it's not a binary input. It's an analog input that's getting converted into a number. If I push the left joystick up, oh, it's not going to do it for me, which means we have a bug. All right, let's go figure out what our bug is. And I think I know what it is. I think we need to import Pygame into main.py. I think I ran into this earlier. We're still not functional. Let's see. I may need to call something in Pygame. Let's say for event in pygame.event.get if event.type is equal to pygame.quit, exit 0. All right, so now you'll notice I'm getting lots of just default responses. So that very small number down here is just with it sitting there. But if I push the controller forward, I now get ones, or forward just a little bit, I get 0.65 or 0.45. So I'm getting readings from the controller. If I go to the left, I get negative 0.38. If I go to the right, I get 0.65. But what we don't want is we don't want the default signals from the controller to result in drift. I'm sure everybody's played a game at some point where your controller was just a little bit, maybe it was a little older. You didn't have the fancy stuff, and that joystick was just stuck just a little bit in the wrong direction, and it made your character want to walk somewhere, or when you let go. That's basically what this would do. If we leave this little bit of drift, this non-zero, it's going to result in a drifting action, which is not what we want. So we're going to basically set a threshold here. So what I'm going to do is we are going to take the mask is going to be np.abs. So the mask is going to be the absolute value of action. and it's going to be greater than equal to or equal to 0.1. We're going to say action equals action times mask. Action equals np.where. Action is equal to negative 0.0, 0.0, or action. And let's just stop there. So what we should get is a bunch of zeros now. But if I move the controller, I get numbers. So now we are effectively passing, all zeros unless unless something changes, unless something happens in here, which is cool. That puts us in a good spot where we are, we're not going to pass anything into the environment that isn't valid or is going to make our environment drift. So let's go over and start working on our actual gym environment. We may need to make a few more tweaks to the controller, but that's fine. We're going to kind of build this up in pieces. So let's go ahead here and we'll set up our gym environment. So we're going to import gymnasium as gym. And we are going to import, we might need NumPy. So let's go ahead and do it while we're up here. NumPy as NP. And down here, we are going to say env is equal to gym.make. And we're going to use Lunar lander continues -v3 with a render mode of human. All right, so what that's going to get us is it's going to get us a successful, it's going to spin up an environment that we can play with and see. And actually, if I just do this right now with no changes, what we should see is we should apparently see nothing because I misspelled or mistyped lunar lander. It should be a capital C. And now we're seeing box 2D is not installed. There's another mistake. I typoed Bax 2D instead of box. Changing it in the file does not fix anything. We actually have to go back and pip install requirements again. And now you can see we are building wheels for collected packages box2d.py or -py. All right, so let's try it again. All right, so somewhere on my screen we might see an environment, except we don't. And I think we don't see an environment because we haven't done our reset yet. So let's go ahead and say obs info equals env.reset. We're not actually going to use either of these. It's just kind of standard. And then just to get a feel for what the action space is, we're going to say env.actionspace.sample. All right. So now we have a lunar lander environment, but it's not doing anything. And it's not doing anything because we're not feeding it any actions. We're not, interacting with it in any way. So we're going to go ahead and close that. And we are going to start using some of our actions. So one of the things we can do here, so action equals controller get action. So we can take some of the actions that we're getting from our controller and we can map them in to the specific actions that we want to use in our environment here. So I'm going to say action is equal to np.array, and in square brackets we're going to grab action 1, and we're going to, for now, we're going to go ahead and say 0. We don't want anything in that next action. And then we are just going to directly pass this in, because what we've basically just done here is we took action from this 5 number array that's coming out of our controller, and we've said, hey, we care about the second action in the list, which the second action in the list is our left joystick going side to side. So we have parsed our second action, and after parsing the second action, we can go ahead and try passing this in to our lunar lander environment. So we're just going to go ahead and say env.step and action. Simple enough. And we will make sure, yep, that's ended down there. Now when I run this and I go side to side, I get a little bit of thrust out of my lander. So let's try that again, because that didn't quite do what I was looking for. And this is where we get into tweaking the results a little bit. So right now I'm pulling back on my joystick, which doesn't quite do what I want it to do. I would like for pushing forward on my joystick to, make the rover go up. So let's go ahead and cancel out. And changing it is actually pretty simple. All we have to do here is and this is what I was starting to do over in joystick controller.py, but let's keep this a little bit simpler, and we're just going to tweak the output over in our main script. So we can just multiply this by -1. Simple enough. So now, as the lunar lander falls, if I push the left controller forward, I get thrust. And I can slowly take off. But I have no way to change side-to-side motion. So that's our next thing to figure out here. So if we come over here to our joystick, our next step is to go ahead and capture motion from that left joystick, or the left joystick on the controller. So we want to go ahead and get axis 2. So I'm going to go ahead and say action 2 is equal to self.joystick.get axis 2. Simple enough. And we will say let's see, action 2, action, that should do most of what we're looking for. So let's come over here and kind of the same thing. We're going to say action 2, and we're going to rerun. So let's see what happens. So our lander starts to fall. I'm going to push the controller to the right, and we're tilting to the right. And if I push to the left, we are tilting to the left. Now, what if we hadn't been successful here? What if our, controller had, what if this was shooting out the wrong direction? Well, if that was the case, then we would basically do the same exact thing that we did before. So we would come in here and we would just multiply that action by a -1, and that would reverse the direction and put us in a spot where we our controls were, moving in the direction that we wanted them to. So that was the joysticks. What if we wanted to use a button? So if we wanted to use a button, and we're not really going to do this much here. I find the joysticks much more useful. But let's go ahead and just find out if the button is, how to do that. So we're going to say if self.joystick, because remember the joystick is the whole controller object. So instead of get axis, it's going to be get button. And we're going to grab the first 0th button. And we are going to go ahead and say action 3 is equal to, let's see. So because this is binary, you can't really assign it the value of the button. We're just going to assign it to, a thing, a value. So I'm going to go ahead and say button 0 is -1. And I'm going to say elif. Nope. self.joystick.getButton. And we're going to go with 2. And I'm going to say action 4 is equal to 1. Or actually, let's go even simpler. Let's just keep it with action 3, and we're going to say is equal to 1. So why would we do that? Well, if using our example here, what if one button was thrust, or one button was left and the other button was right? So let's go ahead and play that out. So we now have our buttons. We're going to grab 0 and 2, and I believe 0 in my case is going to be the left button. For this one it's X, but it's the left button on the right side of the pad. And 2 I think is going to be the bottom, maybe. Let's go play with it. Let's find out. I'm sure there's documentation out there somewhere for this. I have not found it or used it. I have primarily just been, wiring things up and printing out the actions to the screen and figuring out, what did what. So let's go ahead and run this. All right. So if I hit the bottom button, it does nothing. Left button fires to the left, and the right button fires to the right. So I now have the 2 of the buttons on my controller firing off boosters to move the lander in a direction. So again, for this particular use case, probably not really useful. This environment is something you should be able to solve with most standard RL methods. But where this really shines is when you're working with a more complex environment where you need to capture human feedback. Maybe you're working on something where you really just want to hook a controller up to something. Maybe it's not even an RL problem. Maybe you just want to control a robot or control an agent in an environment. This is going to give you a pretty easy way to do this with a simple controller and Pygame. So with that is the end of the video. If you enjoy what I'm doing here, hit like, hit subscribe, hang out. I'm going to continue to talk about robotics and AI and other fun things. The controller I used in this scenario is going to be in the video description. And yeah, hopefully this is useful for you. If you'd like another video series where I am using the same general approach, but with a full use case, something where, I'm capturing human feedback and feeding it into a complex environment, I have another video series called Robotic Manipulation with Human Reinforcement Learning. And I will link that in the video description as well. So with that, until next time.